Alright guys, this is the new video on absolute and percentage error, the next part of your topic. So we've already just talked about how the measurements that you take are comparing against a known scale, and they're always only approximate, they're never the actual real result. And the difference between the actual value and the one that you measure we call the error. So obviously the measured value that you do can either be higher or lower than the actual value, but usually all you're worried about is how big the error was, like how badly you are out. So you don't care if you were under or over the actual measurement. So in this case you're interested in the absolute error. So the formula for the absolute error is here in the blue box here. Absolute error is the approximate value VA minus the exact value VE, and those lines on either side of these lines here, they're modulus lines, and that means that any value within those you convert it to positive. So you don't care whether the approximate value was smaller and the exact value is bigger, you'd get a negative number. You would just convert that to whatever that negative number is to positive. Okay, so those lines on either side just indicate that you only care about the size of the error, not whether it was positive or negative. So an example would be a fence estimated to be 80 meters long. It's actually 82.5 meters long. What's the absolute error in the estimate? Well, I've already given the formula. Absolute error is going to be modulus approximate value 80, which is the estimation, that's the approximation, and the actual value is 82.5, and modulus. So it's going to be modulus of smaller number, take a bigger number, negative 2.5, so 2.5 meters is the absolute error. Alright, next is part of the next set of exercises as well, and it can be easily covered here. A lot of the time that straight number there, that 2.5, can be better expressed as a percentage. So 2.5 is significant for our measurement of 80, okay? But what if it was 2.5 out of like 1,000 meters or even more than that? It's not so significant. So sometimes you express the error as a percentage instead. So in this way it gives you an idea of how many percent you're out instead of actual value. It gives you an idea how many percent you're out from the real value, and the error expressed as a percentage we call the percentage error. So the formula here is actually quite similar to the one before. You'll see the modulus VA take VE. Well, that is the top part there. All we're doing is converting it to be a percentage compared to the exact value. So you're working out how many percent it is, your estimate is, away from the actual value that it's supposed to be. So an example here, a fence, the same actual example, sorry there's cars going by. A fence estimated to be 80 meters long, it's actually 82.5. What's the percentage error this time? So we don't care that it's 2.5 meters out, we want to see how many percent that is compared to the real thing. So percent error using the formula above, modulus, so approximate value 80, take 82.5 over the exact value, which was 82.5, times by 100%. We already know what the absolute error was, which is the top line, so it's going to be 2.5 over 82.5 times by 100%. And I just need to grab a calculator, so give me a second. Alright, here we go. I cannot do 2.5 divided by 82.5 in my head. 2.5 divided by 82.5. So that's 0.030303 recurring, okay? I'm going to times that by 100 and put a percent sign in the end. It's going to be 3.03%, and that was to 2 decimal places because I'm ignoring the other 0303 that's recurring, okay? So what we're saying is that error of 2.5 meters compared to the actual size of 82.5 is actually 3.03% of that. So you're 3.03% out of the real measurement if you think that it's 80 meters. So hopefully that helps you out with the next set of exercises, and I'll see you in the next video.